Hey Global Impact students, this is Mr. Ellinger. This lesson is on solving multi-step equations and inequalities. Our learning targets for this lesson are to solve multi-step equations in one variable, solve equations with variables on both sides. We want to be able to identify equations that are identities or have no solution, and we want to be able to solve multi-step inequalities in one variable. Some essential understanding for this lesson: equivalent equations and inequalities are equations that have the same solution or solutions. The solution of a multi-step equation or inequality can be found using the properties of equality or inequality and real numbers and inverse operations to form a series of simpler equations or inequalities. The properties of equality or inequality can be used repeatedly to isolate a variable. So here's a summary of what we're doing here to solve equations. And these aren't going to apply to every single equation that we come across, but this is the sequence that we need to go through when we're solving an equation. The first step is we want to use the distributive property to remove any grouping symbols. Use properties of equality to clear decimals and fractions also. And we can do those. We don't have to clear fractions and decimals, but we can, and we'll talk about how we can do that in a minute. Step 2 is to combine like terms on each side of the equation. So we're just simplifying each side of our equation, each expression. Step 3 would be to use the properties of equality to get the variable terms on one side of the equation and the constants on the other. Step 4 is to use the properties of equality to solve for the variable. And the last step would be to check our solution in the original equation. When we start off with an equation and we're solving whatever it looks like, equation, inequality, every step that we take should produce a simpler equation. Might be on one side, might be on the other side, could be on both sides, but every step we take produces a simpler, smaller equation until our end result, we have our variable isolated on one side with a coefficient of 1 and a number on the other side. So let's look at some examples here. Our first example, the equation is 11m minus 8 minus 6m equals 22. So we don't have any parentheses to worry about. In this equation, though, we have two m's on the left side of our equal sign. Okay, and remember, I find it helpful to divide our equation, our workspace, into two halves. Whatever we do on one side, we want to do to the other side. And this is if we're moving or trying to isolate a variable. Okay, that doesn't necessarily apply to this case here, because here we have two m terms. We have an 11m and a negative 6m term. We want to combine those two terms into one term. So we can take 11m minus 6m, and that would give us 5m. Minus 8 here, we didn't do anything with that. So our first step is to combine like terms. And when we combine like terms, we get 5m minus 8 equals 22. First step, slightly simpler equation. The next step, here's our variable. So we're going to add 8 to both sides of our equation, trying to isolate m. So this gives us a 0. So we're left with 5m equals 22 plus 8 is 30. Finally, divide by 5, both sides, and we have a solution of m equals 6. All right. Okay, our second example here, we have two fractions. We have b in both numerators, so we want to be able to add these two together to combine like terms. We can't add them together as they are because we know that we need a common denominator here. We have denominators of 5 and 4. So how do we get a common denominator? Well, we look for the least common multiple of both 5 and 4. And in this case, that's 20. So we have to convert each one of these denominators to 20, essentially, and then we'll be able to add these two together. How we do that, 5 times 4 is 20. So we're going to take our first fraction, and we're going to multiply by 4 over 4. Okay, when I multiply by 4 over 4, what am I multiplying by? I'm multiplying by 1. I can multiply anything by 1 without changing its value. It doesn't look like 1, but this is a very powerful tool in math. We can create 1 however we want to, as long as the numerator and the denominator are the same. In our second fraction, we need the denominator to be 20. We need to multiply 4 by 5. So we're going to take our fraction as is. We're going to multiply the numerator by 5 and the denominator by 5. When I do that, I get 8b over 20 plus 15b over 20 equals 3. And now I can add these two together. When we add two fractions, we just add the numerators. So we're left with 23b over 20 equals 3. Trying to isolate b, divided by 20 here, so we need to multiply both sides of our equation by 20. 20s will cancel on the left. So we're left with 23b equals 60. Divide both sides by 23. B equals, now what do we put here? The tendency is to pull out our calculator, divide 60 by 23, and put 2 point whatever for our answer. Round it, to the 10th or the 100th. We'll, the best decision as far as answer goes, fraction answer. Try to reduce it if you can. The original problem had fractions in it, so it makes sense to have an answer that has fractions in it as well. The other method here that I wanted to talk about for clearing fractions, because our previous slide discussed clearing fractions, and it's similar to using the common denominator, the least common multiple. The least common multiple, we said, of 5 and 4 was 20. Rather than converting these two denominators to 20, what we're going to do is we're going to multiply the whole equation by 20. And I'll write out the step of what this looks like. It's the distributive property. So we'll do 20 times 2b over 5 plus 20 times 3b over 4 equals 60. 3 times 20 is 60. Now, when I multiply 20 times 2b over 5, what's happening here is I'm going to multiply 20 times 2b, which is 40b. Focus on the 40. 40 divided by 5 is 8. So when I multiply here, I get 8b. Here, I do 20 times 3, which is 60. 60 divided by 4 is 15. So I'm left with 15b there equals 60. That's what it looks like to clear the fractions. Again, find the least common multiple of the two denominators, 20. Multiply the whole equation by 20, and that wipes out your fractions, and now we're left with an equation that has no fractions. Combine like terms on the left side. Divide by 23, and we get b equals 60 over 23 again. Our answer is most precise when it's a reduced fraction. If it winds up being a terminating decimal like 2.5 or something like that, that's okay. But if it's something that we have to round, it's bad, because remember, what should happen here is our solution, we should be able to take this solution and substitute it back into our original equation and get a true statement. If you start rounding decimals to the 10th or the 100th or the 1000th or whatever, you plug that value back into the equation and it's not going to give you a true statement, and that's a problem. All right, our third example here, we have 18 equals 3 times the quantity 2x minus 6. So I'm going to show you two ways to solve this one as well. The first method is to, let me just put a different equation up here. If I told you to solve 18 equals 3b, you would say, oh, I'll just divide by 3 both sides to get b by itself. This b is some quantity. Think of this parentheses here as b. It's some quantity. It is a quantity. It's in parentheses, and we refer to it as a quantity. It's an unknown quantity. So my equation is 18 equals 3 times some quantity. So what I could do is to divide both sides of my equation by 3 right from the get-go, and that gets rid of the 3's here. Essentially, it leaves 2x minus 6, that quantity. And once I don't have this coefficient of 3 here, I can eliminate the parentheses. 18 divided by 3 is 6. Add 6 to both sides. I get 12 on the left. I have 2x on the right. Divide by 2. X equals 6. Okay, so that's a little trick here. Anytime you have a number in front of parentheses, you can divide by that number on both sides and get rid of that number, dropping the parentheses. Only in a problem like this. If there were other terms over here, we wouldn't be able to do this. But for problems like these, we can do that. All right, so here, let me show you the other way. The other way is to get rid of the parentheses in a different way using the distributive property. So if I use the distributive property on this problem, 3 times 2x is 6x. 3 times minus 6 is minus 18. Remember, when I distribute 3 times this, I've got to look to the left for the sign. That 6 is like a negative 6, so I'm multiplying 3, positive 3 times a negative 6. I get a negative 18, so I'm putting minus 18. Next step would be to add 18 to both sides. I have 36 on the left. I have 6x on the right. Isolating x, I'm going to divide by 6. And so I'm left with x equals 6. 36 divided by 6 is 6. I just flipped the equation over. Symmetric property of equality. A couple of different examples here. Here we're looking at equations that have variables on both sides of the equal sign. And if we don't have any grouping symbols here to worry about, we don't have any fractions, the very first thing that should pop into your head is I've got to get all of my, in this case, k's, all my k variables on one side. So we're going to move, if you will, the term that has k, all those to one side. And we do it the same way as if we were moving a number. We're going to add or subtract. So let me draw my line. I want to combine 4k with 7k. But since 4k is on the opposite side of the equation, I have to subtract it. It's positive on this side. I have to subtract it to the other side. And since I'm working with k's, I'm going to write this 4k under the 7k. Okay, just so I keep my work nice and organized. 4k minus k, that gives me a 0. Much as if it was 4 minus 4 would give me a 0. So on the right I'm left with a negative 10. I'm going to combine these two. 7k minus 4k is 3k. I'm not doing anything with the plus 2 yet, so I will just bring it down. Okay, so as you can see, when I went from the starting equation to my next equation after I've done a subtraction property of equality, I'm left with a simpler, slightly smaller equation that's a little bit easier to solve, a little less intimidating looking. So here's k, 3 times k. I'm going to do inverse operations here to get rid of this plus 2. I'm going to subtract 2 from both sides. Plus 2 minus 2, that's a 0. Bring my 3k down. Equals negative 10 minus 2, negative 12. Divide by 3. K equals negative 4. Again, we can always check our solutions. I haven't been checking them, but I could always do that. If I put negative 4 in for k here, 7 times negative 4 is going to be negative 28 plus 2. We want to know, does that equal 4 times negative 4, which is negative 16, minus 10. Negative 28 plus 2 is negative 26. Negative 16 minus 10 is negative 26. So it checks out. That is the solution. Our next example, we have parentheses on both sides. We have y's on both sides. The tendency here is to probably just go ahead and use the distributive property. And we can. Okay, so the first step would be to multiply 4 by 2y and plus 1. So 4 times 2y is 8y. 4 times positive 1 is positive 4. On the right side, 2 times y is 2y. 2 times the negative 13 is a negative 26, so I'll put minus 26. Here's our equal sign, so we'll split our workspace up into 2 halves, 2 parts. I have an 8y over right here on the left. I have a 2y on the right. I'm going to subtract the 2y from both sides. It's positive on the right, so I've got to subtract it. 2y minus 2y, those are going to give me a 0, so they cancel each other out essentially. Bring down the minus 26. 8y minus 2y is 6y. Didn't do anything with the plus 4, so just bring it down. Here's y. Remember, we're isolating y. Subtract 4 from both sides of the equation. Here I get a 0. Bring my 6y down. 6y is going to equal negative 26 minus 4. Remember, we're working vertically. Do it just as it says. Negative 26 minus 4. That is negative 30. I'm going to divide by 6 to isolate y. So y is negative 5. So a couple special cases here. An equation that is true for every possible value of the variable is what we call an identity. For example, x plus 1 equals x plus 1 is an identity. No matter what x is, that is always going to be a true statement. If I take x and add 1 to it, on the left side, it's going to equal whatever x is, adding 1 to it on the right side. An equation has no solution if there is no value of the variable that makes the equation true. For instance, the equation x plus 1 equals x plus 2 has no solution. You can't take a number and add 1 to it and have that equal taking that same number and adding 2 to it. Okay, so my first example here, I have 3 times the quantity 4b minus 2 equals negative 6 plus 12b. So if I didn't know any better and I was asked to solve this problem, I would distribute the 3. 3 times 4b is 12b. 3 times minus 2 is minus 6. Negative 6 plus 12b, I can't do anything with that. Now I may get to this point and notice, oh, I've got 12b and 12b, I've got minus 6 and minus 6. That's kind of weird. But I will go ahead and collect my b terms on one side, so I'm going to subtract 12b from the right and the left so that I can get all my b's on one side. Here I get a 0b, which is 0. I get negative 6 only. Well, 12b minus 12b, I also get a 0 on this side, and that leaves negative 6. Essentially eliminate all the variables, leaving just some numbers, and the number on the left, negative 6, equals the number on the right, negative 6. That's a true statement. So really what that means is this is what we call, this is an identity. This equation is an identity. Meaning b can be anything. Okay, normally when we solve an equation like this, there's only one solution for b, but in this case b can be any value. If b is 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, 1 half, 1/4, 0.575, anything. If I plug b, that value in here and work out the left and the right, I'm going to get the same answer. So there's an example of what happens when you get an identity. Okay, if I were to solve this equation, on the left, I'm not going to do anything, no simplifying to do on the left side. Here, I've got a negative sign in front of parentheses. Remember, this is like a negative 1 here. So I'm going to distribute the negative, or distribute negative 1. Negative 1 times 3 is negative 3. Negative 1 times negative 2x is positive 2x. Only want one sign here. So then I look at this equation and I say, okay, both sides are simplified. 2x plus 7, negative 3 plus 2x. Now it's time to start collecting like terms on each side. So I'm going to get my variables on the left. So I'm going to subtract 2x. This gives me a 0. Subtract 2x. Bring down the negative 3. 2x minus 2x. Here I have another case where the variables are completely eliminated from the equation in the solving process. I bring the 7 down. Now I have a statement 7 equals negative 3. That is a false statement. Okay, so this is not an identity. What this tells us is that there is no solution to this equation. No solution. There is no value of x that will make this equation true. None. I don't care if it's a fraction. I don't care if it's a big long decimal, a positive number, a negative number. Nothing that you plug in for x will give us a true equation. So there's no solution there. All right, so let's look at some inequalities here. Same process, only we have to remember our dividing and multiplying by a negative number with the inequality. So, but here here's my variable a, I'm going to add 7 to both sides. Here's my inequality. So here I get a 0, negative 6a less than or equal to 17 plus 7 is 24. I'm going to divide by negative 6 to get a by itself. Remember, negative 6 divided by negative 6 is a coefficient of 1 on a. That's what we want. I divided by a negative, so I need to reverse the inequality. 24 divided by negative 6 is negative 4. So my solution is a is greater than or equal to negative 4. 15 is less than or equal to 5 minus 2 times the quantity 4m plus 7. I can't do anything with the 15, it's already simplified. The 5 minus 2, I have to multiply first. Okay, I can't subtract anything yet. I have to multiply, I have to distribute the 2. And this is a minus 2. So I'm going to think of this as negative 2 times 4m. That is negative 8m. And I'm going to go back to this negative 2 times a positive 7. That is a negative 14. Very critical there with the signs in that step. I'm going to simplify the right side. I can combine 5 and negative 14 or minus 14. That's a negative 9. And I'll put my variable term first, negative 8m, not combining it with anything. And I got a minus 9. Again, these two combine to give me a minus 9. So here's my m. I want to isolate it. I'm going to add 9 to both sides of my inequality. And I forgot to draw my line. This gives me a 0. So I will bring down my negative 8m. 15 plus 9 is 24. Isolate m, I got to divide by negative 8. When I divide by negative 8, I've got to flip my inequality. 24 divided by negative 8 is negative 3. M on the right side. So negative 3 is greater than or equal to m, or another way to say that is m is less than or equal to negative 3. All right, sometimes solving an inequality gives a statement that is always true, such as 4 greater than 1. In that case, the solutions are all real numbers. If the statement is never true, as in 9 less than or equal to negative 5, then the inequality has no solution. So this is kind of similar to the identity no solution situation with equations, only we're going to wind up with an inequality statement that is always true or never true. Okay, first example, we have 9 plus 5n is less than or equal to 5n minus 1. So we have no simplifying to do on either side of the equation. We can just start collecting like terms. So we're going to subtract 5n from both sides. All right, 5n minus 5n gives me a 0. And over here, 5n minus 5n also gives me a 0. So the only thing that's left on the left side is a 9 less than or equal to. The only thing left on the right side is a negative 1. We have a false statement. False statements tell us no solution. Second example, 8 plus 6x, we cannot simplify that at all. 7x plus 2 minus x. So we can combine these two. 7x minus x, that's a 6x. Plus 2. Now I'm ready to start collecting like terms, so I will subtract 6x from both sides since I have x terms on both sides. 6x minus 6x is 0. Again, 6x minus 6x is 0. So what am I left with? On the left side I have an 8. I still have a greater than or equal to symbol. On the right side I have a 2. That is a true statement. 8 is greater than or equal to 2. This tells me that the solution is all real numbers. Okay, that's the correct mathematical statement for x can be anything. Another application problem. We want to make a rectangular banner that is 18 feet long. You have no more than 48 feet of trim for the banner. What are the possible widths of the banner? Our variable in this case is W is the width. Now we need an equation or an inequality. In the problem here it says no more than. What does that mean mathematically? No more than means it can't be greater than, right? So it has to be less than. Now, no more than 48 means it could be 48. So what we've got here is we have a less than or equal to 48 situation. The question is, what goes here on the left side? What is less than 48? Well, we have a rectangular banner, so right there we have a clue. We're working with a rectangle. And it says you have no more than 48 feet of trim for the banner. Now trim, what is trim? Trim means around the outside. So if this were my banner, the trim would be here, 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 and here. Okay, sorry. That's a perimeter problem. How do we find the perimeter of a rectangle? Well, perimeter, we know we add all the sides. So if this were the length and the width and the width, we know that we would add all these together. So W plus L plus L, or you may have seen before, 2W plus 2L is the perimeter. Well, the perimeter has to be less than or equal to 48. However, in this problem, we know that the length is 18 feet. So we can substitute that value in. 2W plus 2 times 18 has to be less than or equal to 48. So 2W plus 36 has to be less than or equal to 48. Subtract 36 from both sides because we're trying to solve for W. We get 2W is less than or equal to 12. We divide by 2 to isolate W. We get W is less than or equal to 6. What are the possible widths? How could we express that? Well, the width is less than or equal to 6 feet. You know, we don't really need to reference the fact that it has to be greater than 0. We're talking about measurements here, so I think that it could be understood that we're going to go ahead and assume that it's going to be greater than 0. Okay, important lesson there. Hope you guys have a great day.